All right. So to verify the scale factor, we're going to prove the 2, which means we're going to show that this image and pre-image has a ratio of 2. This pre-image image has a ratio of 2. And then this one that you can barely see has a ratio of 2. So it's a lot of Pythagorean Theorem. So here we go, and we'll count. And then I will write on scratch paper to kind of give you guys a visual of it, because I know it's getting a little crowded here. All right, so look. Pythagorean Theorem. Here, let me just put scratch paper. All right. It's this, or you could think of it as, and this is the one we're going to use. All right, and so we're just going to go to calculator in your phones. You guys are fine with your phones. You just have to go landscape. And we're going to get decimals, probably. Okay, so look. If you remember on a right triangle, when it doesn't matter how it's drawn, all right, your AB are your legs, meaning they're the ones, see how when they come together, it's the 90 degree? Your C is always opposite the 90. So see how there's my 90 degrees, 90 degrees. The hypotenuse, or your C, is always opposite the 90. C is a hypotenuse, AB are legs. So when we go into this dilation, pre-image, image, we're going to find the lengths. The lengths are all the C's, the hypotenuse sides. They're all the slanted sides, because when we look at the triangle, they're not vertical and horizontal lines. They're diagonal slanted segments. So it's our C. So some of you will follow along perfectly on our graph paper with everything written, but I'll also go to this little white sheet of paper, draw the pre-image and the image separately, of course, and I'll count and kind of show with dashed lines like where the numbers are coming from and the calculations, so that you can kind of see it without so much written noise. Okay, so what I mean is, if I kind of take this pink triangle, how does it look? Okay, it's ABC. I want to find the lengths. I want to find the length of AB, BC, and AC, okay? All right, but these are all slanted segments on my coordinate, right? So that's where the Pythagorean Theorem kicks in. Okay, so I'm going to count horizontally and vertically, and I'm going to find my A and my B, and I'm going to square it, add it, square root it, and that's going to give me the C value. So if we count, see if I can show both, hold on. Yeah, so if we count, so I'm going to start at A, I'm going to run across, and then I'm going to come down. Okay, so if I count, it's 1, 2, 3, 4. So it's 4 across, and then it's 1, 2, 3 down. Yeah? So that means A, B, C. So what my Pythagorean theorem is looking like, 4 squared plus 3 squared. Because those are my legs. My hypotenuse is the segment AB. Keep going. Yeah? Okay. So then what is 4 squared, 3 squared? 16 plus 9, which is the square root of 25. And the square root of 25 is just 5. So if my hypotenuse is 5, that means AB is 5. So this is 5. So we're going to do it 5 more times. Okay, I wrote this on paper so it's nice and clear. If you're not writing it on paper and you want to put it on this graph paper, that's fine. Hold on. I'll put this back. You can just go AB, you put your square root, and you count. So 1, 2, 3, 4, 1, 2, 3, 4 squared, 3 squared, and then there's your 25, and so AB is 5. And so we're going to do it for the segment BC and the segment AC. We're going to do it 2 more times for that triangle to complete it. Yeah? So I'll show you both. I'll do it on this paper so you can kind of, because it'll get messy if I start writing all these numbers here. Okay, if we look at BC, it's up to you. If you want to go left down, you can, or we can go down left. Yeah? Okay, so if I go down, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So let's count it again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So BC is 5 by 6. And if you're capable of counting, you can go straight to the calculator and, you know, I'm going to write it, but you can go straight to the square root, 5 squared plus 6 squared, hit equal, rad 61, we're going to get a decimal here, you're going to get 7.8, but I'll do it again, okay? So my C is 5 squared, 6 squared, 25, 36. So now maybe you want to go to a calculator. What's square root 25 plus 36? 61, but I want a decimal, so you hit SD, and I get 7.8. And so BC is 7.8. But for those of you that want to put it here, and now we'll do AC. How's it going? I'm recording. All right, so AC, let's count. 1, 2, 3, 4. Hold on. Yeah. 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What did I say? 4, 16? Okay, 16 by 4. That's supposed to be right. Keep going or wait? Yeah, Anthony.
Why did you do that one?
Oh, you guys, I did the green. Are you saying I did the green?
Yeah.
Oh, you guys. Okay, pink. Hello. I got excited. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 2, 8. Thank you, Anthony. Oh my God, I would have got the numbers. 2, 8. All right, so then C is equal to 2 squared, 8 squared. And again, it doesn't matter if you did 8 squared plus 2 squared. It's addition. All right. It's commutative. Okay, so 4 plus 64, 68. What's the square root of 68? 8.2. And so that is AC. Okay, so we have the 3 lengths for the pre-image. Now we got to do the image. Like I said, I do it once with you guys so that you see the verification of it, but you're not asked to do this on a quiz or a test, okay? Okay, so there are our values. And now we'll do the green. So these are the pink. In fact, I'll do pink, just so I know. I'm gonna need more paper. All right, go to green. Move this. Yeah. No. All right. So then the green. Let's draw a bigger. So this is A prime, B prime, C prime. So again, we're going to count. Okay, we already know this is 4 by 16. So you're going to count the legs that create that hypotenuse, right? Okay, so now how can you go a little faster? You can just start counting them all in one shot. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So let's do it again. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. And then the big one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12. Wait, I think I need one more here. No, I'm good. No, we're good. Okay, 10, 12. So I count all along. Those are your values. This looks like a Y. It's a 4. And now you're just going to perform the Pythagorean Theorem because we need the segment lengths. And then we're going to create 3 ratios to prove K is 2, K is 2, K is 2. Keep going? Yeah? Okay, so let's start here first. So 8 squared, 6 squared. 64 plus 36. It's going to be 100. All right, 64 plus 36 is, oh, it is showing me the 100. Okay, it's just 10. This is a square root of 100, which is 10. So A prime, B prime is 10. You would put the little prime so that you know it's distinguished from the pre-image, because that's your image. Do you want me to just keep going? Yeah? Yeah. Okay. All right, so I'll do this one next. And then if I make a mistake, please say something. Here. This is 16. 256? Yeah. Oh, wait. Oh, hold on. Just because if you're using your phones. Okay, there we go. What was that? This one? Okay. And you're going to do a lot of this as we move forward with the trick, so you just... That's why I like reviewing this with the dilation. I know it's a lot of extra work, but I like kind of introducing it because it's so easy to dilate. You just multiply. So if you kind of take the lesson, go over Pythagorean Theorem, it's like an early lesson to later on with the trig, so that you've already been exposed to it. You'll see it like 6 times. You'll see it one other time, just so that you're familiar with it in about a few weeks from now. Okay, so I'm going to kind of transfer it to this paper here. I'll put it like over here. Hold on, I'm trying to show you. And remember, all this is getting recorded. The video has to be so long. How did I do it here? Oh, I just wrote it. Okay. And these are, this is the image. Anyone still copying? You are. How much more do you need? Okay. On this one or this one? This one? Okay. So we're now just going to take a ratio and we're going to go green over pink. It's image over pre-image. So when you take the corresponding sides or segments, it's big. Well, in this case, because we magnified, it's going to be big over small, but it's always image over pre-image. So it's the primes over the non-primes. Always, if you were to flip it, your scale factor is reciprocal. And so instead of magnifying it, you shrunk it. So it does matter. Okay, all right, so look, when you're verifying your scale factor, so we're kind of looking here, your scale factor, in this case it's K, right? It is always image over pre-image, or it's always, in this case, it's triangle, ooh, can I fit? I'll do it over here. It is, so I'll put K. It's triangle A prime, B prime, C prime over triangle A, B, C. Primes over non-primes. Image over pre-image. Green over pink. So I'm going to put a little green and a little pink. And so now we're going to verify that the sides do in fact, we're going to verify that we better get a 2. And that we magnified correctly. And you guys could already tell by the numbers that you're doing it right. So I'm going to take A prime B prime over AB. So A prime B prime over AB is, what's 10 divided by 5? 2. Perfect. So take the next corresponding sides. B prime C prime over BC 15.6, 7.8, and that is 2. And then take the third. All right, we're a little off here. And it's by significant figures. Because what was 272? Yeah, 272 is 16.49. And then rad 68 is 8.24, so it's still 2. So if I was to take, hold on, rad 272 down rad 68, if say you didn't change it to decimals, there's my 2. Okay, so it works. If you ever think your sig figs are off, just put it in with the radical and you'll see. And so there's our verification. And actually, what else would show? You're like, no, stop talking. If you were to sum the sides to get the perimeter of a triangle, that would also be 2. So if I even wanted to get the perimeter, right? Okay, what's a perimeter of triangle A prime, B prime, C prime? Well, you would add up these 3. So what's 10 plus 15.6 plus 6.5? 10 plus 15.6 plus 16.5. Whoops, don't do that. Is 42.1. What's the perimeter of my pre-image? Well, what's 5 plus 7.8 plus 8.2? 15, 20, 30? Oh my gosh, hang on. 7.8 plus 5, 21. And notice, what's 42.1 divided by 21? It's about 2. So your scale factor is maintained. It's called isometric. It's maintained through dilations. It should stay. It doesn't dilate irregularly, like one side gets larger over the other side. It completely magnifies perfectly in proportion. Okay, I'll stop, because I gotta stop the video too. That poor, oh wait, I'm recorded. Yeah.